This rule, this Hund's rule, for the filling of the electrons in the orbitals belonging to the same subshell. Same subshell means azimuthal quantum number should be same. This rule says that the pairing of electrons in the orbitals belonging to the same subshell, that means P, D or F, it does not take place until each orbital belonging to that subshell has got one electron each. That means each orbital, first it will be singly occupied by electrons, and after that only it will be paired with another electron. So I'll describe this with this figure. To consider these p orbitals, that means in p subshell, here has the orbitals px, py and pz. The notation is p always in small letter. Then first, if one electron comes, then it will come here. Next electron will come here. And third electron will come here. This px, py and pz, all in respect of energy, it will be equivalent. I already described this in the previous class. So the first three electron, it will be occupied, singly occupied by each orbitals px, py, pz. If fourth electron will come, in that case, the one orbital, in this case the px I have written, this will be paired. That means two electrons will be present then in px. That means now for the p subshell, that means in p orbitals, it has the px, py, pz. That means first three electrons will be unpaired in each orbitals px, py, pz. If fourth electron you need to add, then one orbitals, in this case px, will be paired. And if the fifth electron will come, then it will be occupied by the py. And if sixth electron come, it will be occupied by pz orbitals. That means in the last row you see the all orbitals px, py, pz, these are paired. In case of D also same thing will happen, that first 5 electrons singly occupied by each of the orbitals dxy, dyz, dxz, dx square minus y square, dz square. And then if sixth electron will come, then it will occupied by the one orbitals and it will be paired. And similarly, the next electron, when with the number of electron increase to enter these d orbitals, then one by one each orbital will be paired. And finally, if 10 electrons comes, then every orbital dxy, dyz, dxz, dx square minus y square, dz square will be paired with electrons. That means each orbital will have the 2 electrons. In this case, one thing we have to remember that dxy means d subscript xy. In this way, the other orbitals also notation is there. And so it has been observed that the half-filled and fully filled degenerate set, these all are degenerate. It is called the degeneracy. So I think that I already explained this. And in this case, the half-filled and full-filled degenerate set of orbitals acquire extra stability due to their symmetry.